Thanks for joining me in this exciting video about electron excitation. Now, let's talk a little bit, let's refer back to some key terms. The ground state is the lowest state possible. It's when attractions have been maximized and repulsions have been minimized. Okay, and for aluminum, this is the ground state. It's what your periodic table is going to predict for you. So when you do your electron configuration from the periodic table, you're predicting a ground state electron configuration. Now, if I knew this was aluminum, this would be an ion. You notice that my 3 valence electrons, my outer S and P electrons, have been lost. So this would represent the aluminum 3+. That's what happens during ionization, loss of electrons. They are ionized. They are no longer attracted to the nucleus. They've been transferred someplace else, likely another element, like a non-metal. Okay, and that would form the aluminum ion when it's ionized. In an excited state, so this is representing what we might call an electron density diagram. It's like if you took a kabillion pictures of an atom and mapped its electrons over all of that time. This would be kind of the place where they'd most likely be found is here, and then a little bit less out here. This shows an excited state. You notice electrons further away from the nucleus. So how you could recognize that? Well, for one, if you see a G sublevel, you know it's excited. It's usually not that obvious. If you notice, this order is not exactly what you would get from the periodic table. One of these electrons is at a higher energy level. So when you see an electron, they're still all present. I still have all 13 electrons, but one electron from the S moved to the P. This is higher energy. That would represent excited. Doesn't have to be the next one down. It could have been moved to the 4S. It could have been moved to the 3D. Could have been moved to an F. It depends on the incoming energy, how far it would move from the nucleus. Okay? Now, how about this next one? Could it be an excited state or an ion? Well, what you always want to look at is this. S can have 2 electrons, but you notice that S has 3 electrons in it. That is not quote unquote allowed. What that means is it's not physically meaningful. It just doesn't happen. The model doesn't match the behavior we see. So that is simply not allowed. This is just plain wrong. It's not excited. It's just wrong. Okay, so this S electron, what didn't take from the 1S to the 2S, you can't do that. If an electron's going to be excited, it has to be excited to an empty orbital space. You can't have excitation into a full sublevel. And so that's why this is just plain wrong. Now, had that been a 2 there, then yes, we could have had a different conversation. But always take a look and make sure that your sublevels have the right number. So check your sublevels when you see. These are typically multiple choice questions. So always check your sublevels to make sure they have the correct number of electrons and no more than they are allowed. Okay, so quick little introduction and an explanation of what it would look like to see excited electrons. Electrons that have gained energy, they're a little further away from the nucleus, They've absorbed energy from electricity or a Bunsen burner, or electromagnetic radiation. Somehow they have gained energy, and they're at a higher energy level in a higher sublevel than what would be predicted by the periodic table, which is their ground state. So hope I helped. This is a little complicated. So you might have to rewind and watch it again. If you're my kiddos, you might need to come in for a little extra help on this one. Thanks for watching. I appreciate your time.